Okay, students, so welcome to the day 7 of the rapid revision session for the 2026 students. Alright, so today we'll be discussing regarding the half ladder, full ladder, and flip flop. So y'all can check the other sessions which were done on the lesson logic gates, or as we did 2 sessions on the number systems as well. So y'all can check the previous videos as well. So now, as for the day 7, we are discussing about the half ladder, full ladder, and the flip flop. These are very important. Okay, these three types of gates are very important. Okay, now when it comes to circuits, okay, so when it comes to circuits, there are two types. One are combinational circuits. Combinational circuits. The other type is sequential circuits. Now, what is the difference between these two, right? So, as for the combinational circuits, it only takes the input, and gives out an output, right? So, it depends only on the inputs. Now, as for the sequential gates, it depends on both the input and the previous output. Now, let me draw a simple structure and try to explain this. Now, as for the combinational circuits, now the circuit would be in the middle. So whatever the circuit is, the circuit would be in the middle. There will be inputs, right? These are the inputs. And there will be outputs as well. Okay. It depends, right? How many inputs, how many outputs, it depends, but this is basically what is happening. So the outputs, it depends on the inputs only. Now, as for the sequential circuits, the difference is, now there will be inputs, but the input would depend on, the output would depend on the previous output as well. It's kind of like a memory, right? All the outputs are kept in a memory, and that output will affect the next output as well, right? So it depends on both the inputs and also previous outputs, right? So that's the difference between the combinational circuits and the sequential circuits. You all understand this more when we are doing the examples, right? Now, now let's see these two, right? So, for example, as for the combinational circuits, examples are in your syllabus, it is the half ladder and full ladder. So that is a combinational circuit. Now, as for the sequential circuit, we have the flip-flop, right? So flip-flop is a sequential circuit. When we are doing the example, you will see how the flip-flop works, right? Then it will be easy for y'all to understand this. So these are the two times. So y'all should remember. So what is happening? So when it comes to the combination, the outputs will only depend on the input. But when it comes to sequential, the output will depend on the inputs and also the previous output as well. All right. So This is a basic explanation. So let me so let's start with the half adders, full adder, and then let's move to the flip flops, right? Okay, now half adder. Now half adder. So when it comes to a truth table, okay, when it comes to truth table, there are only, so in a half adder there will be only two inputs, right? So we got A and B, right? So half adder will have only two inputs. Now what are the inputs? 0 0 1 1 0 1 0 1, and then we are gonna find the sum, and there is another one called the carry out, which is the carry bit, I mean the bit which we are gonna take forward. Now when we add 0 and 0, okay, when we add 0 and 0, the answer would be 0, and there won't be any bit which we are taking forward. When we are adding 0 and 1, the answer would be 1. Still, there won't be anything we are carrying forward. Then after that, we got 1, 0. The answer is still 1. Okay, there won't be anything which we are carrying forward. But when we are adding 1 and 1, the answer would be 1. Sorry, the answer would be 0. When we add 1 and 1, the answer would be 0. But then we are carrying out a bit forward, that is 1. Now, let me write down the SOP expression for the sum. Now, this is A bar dot B plus A dot B bar. If you all have forgotten how to write the SOPs and the POS, you all can check our previous videos. I have explained it. So, now what is this? මෙයා කවුරු වගේද? මේ A dot A bar dot B plus A dot B bar කියන්නේ කවුරු වගේද? This looks like this is equal to A XOR B, right? Then I'm gonna write the SOP to the carry out. Now that is just one is there, so that is A dot B, right? A dot B. Now, when we are drawing the circuit, students, now sum is going through an XOR gate. Sum is going through an XOR gate. Right? So that is sum. Then also, the carry out is going through a simple AND gate. Now that is the carry out. We can call it carry bit as well. So what the bit which we are carrying forward. So now this is what a half adder gate looks like. A half adder circuit looks like. So it is joined by an XOR and also an AND gate. Hari XOR gate tekai. We got the XOR gate and also the AND gate. Right? So that is the half adder. Okay, I hope you all understood this one. Then let's move to the, y'all can pause the video, get a note down, right? If you have forgotten this stuff. If you are here for the flip-flop part, if you have understood the half ladder and full ladder, you can skip to the, the kind of like the last part of the session and check the flip-flops as well. All right, so full ladder. Now, this is also a combinational circuit. It has three inputs. So now we are considering three inputs. A, B, C, and some carry out. Okay. 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay. Now, if you add in three zeros together, three zeros now, sum is 0, carry out is 0. If you add in 0, 0 and 1, it would be 1 and still the carry out is 0. Here also the similar result, it will be 1, 0. If you add in two ones together, then 0, the carry out would be 1. Here also it's 1 and 0. Here once again 0 and 1. Here even 0 and 1. If you all have forgotten this addition, check out. There is a session called the addition and subtraction of in the number system. Y'all can check it out, right? At the beginning part, I discussed about the binary calculations, right? Okay, then three ones together. Three ones can ekak tyagana. Let's say 2 is going to the other side, so that would be 1. So this is the answer. So for the sum, let me write this. So okay. Now A bar B bar C plus A bar B C bar plus A B bar C bar plus A B C. Okay, now the thing is, now there is a bit of a catch in here, right? Now, when you look at this one, okay, when you look at something like this, okay, y'all can see now here we got A bar, and then there is a 2 which doesn't have a bar. Then we got B bar, then there is 2 which doesn't have a bar, B and B. Then there we got C and C bar and 1 which doesn't have a bar. Okay. If you draw a Carnot map, even y'all can understand this one. There are two ways to actually get the answer for this. Now, one way is, right? Okay, let me draw the first way. Let's say we do it using the Carnot maps. Actually, we can't get a direct answer, but I'll show you all the pattern which is normally occurring. Okay, so A, B, C, this one. Then we got A bar, B, C bar, this one. Then we got A, B, and C this one. Then finally this part A, B bar, C bar, this one. So if you all gotten something like this, student, right? If something like this, which is like a pattern which goes diagonally, right? Okay, something which goes like this, then this would definitely be an XOR gate, right? Now that is the Carnot map method. Now we can try to prove. Okay, we got the answer. So this, remember, students. Now both the all these half adders, full adders, flip flop, those are theoretical lessons, right? So for the exam, you have to by heart this one, and it's a theoretical based lesson. There's no time to think and write. Okay, so it's better if you all have understood everything, if you all can remember everything. Okay, so basically it's better if you all can remember. It's not better, it's a must to remember that sum is equal to A XOR B XOR C. Now as for the second method, okay, as for the second method, now I'm going to take this one. Yeah, I'm trying to prove whether I'm getting the similar answer. Right? We know that A XOR B is equal to A B bar plus A bar B. You already know this one. Right? Now imagine these are again two individuals together. Just imagine this part is X and this part is C. Right? දැන් අර මේ කතාවම ආයෙත් ඇප්ලයි කරන්න පුළුවන් නේද? A B bar plus A bar B dot C ඒකේ අනිත් පැත්ත දාන්න පුළුවන් A not dot C bar එකක් දාමු A B bar plus A bar B bar dot C අර මෙයාගෙම නිකන් අපි මෙයා මම නිකන් X කියලා හිතුවා. හරි. එතකොට නිකන් මම ලියන්න හදන්නේ මේ x dot c bar plus x bar dot c කියන්නේ ආයෙත් අර XOR කතාවනේ. සුමි x එකයි x bar එකයි. Now try to solve this one. So in here we got a b bar c bar plus a bar b c plus, then we have to remove the bar here. So a b bar plus a b bar dot c, and this becomes 0 as well, right? Okay, now what we are going to do is we are going to break it once again. A bar plus b, a plus b bar. So we multiply them together. A dot a plus a bar b bar plus ab plus b dot b bar and c. So this is 0. This is also 0. So finally we got a bar c bar plus a bar b c plus a bar b bar c bar plus a b c. So this is the similar answer which we are getting, right? එකම answer එක තමයි අර මෙයාව අනිත් පැත්තට solve කරපුවාමත් දෙන්නේ. හරි? Now okay, now we could get this one to carry out as well. SOP. Now that is A bar BC plus AB bar C plus ABC bar plus ABC, right? Now, okay, now what I'm gonna do is I'm gonna take, so in here I'm gonna take BC out, A bar plus A plus, then here can we take anything out? No, right? This is 0, okay. Then we got BC plus AB bar C plus ABC bar. Okay, no, this is one, sorry, mistake. Okay. Then take C out from here. Then we got B plus B bar A plus ABC bar, right? So this is equal to B plus A, right? Redundancy law. We have already done this one. Okay, y'all can check the videos. Okay, then take A out from here. So we got C plus BC bar. So that is once again equal to BC plus this one is C plus B. Then finally we got BC plus AC plus AB. So let me write that down nicely. AC plus BC. Okay, so this is the final answer which we are getting, right? Okay, so now what we're going to do is, now this is the answer, right? So with this one, we are going to, now we got the sum and the carry out as well. Now we have to draw the circuit. So let me erase this one, the truth table part. Now what has happened is A, B and C. So there are three inputs which are which are A, B, and C. Okay, now A, B, and C, both of the, all three of them are going through an XOR, so we can draw that one. So this is the sum, okay. Then A, B is going through an AND gate. Then A, C is going through an AND gate. Then BC is going through an AND gate, right? So y'all can see, right? Okay. Now, all three of them are going through an O gate. So that is the carry out, right? So this is the full ladder circuit, right? So this is the full ladder circuit. Now, there is another part where you can draw the full ladder with the half adder. I'll do it in the next session because now since we are like going through the theoretical part, so this is the full ladder circuit and the half adder we did it. So then let's move to the flip-flops, right? Now this is very important because most of the students find it very difficult to understand, right? Mostly because of they try to understand the circuit and then yeah, it makes it kind of difficult for some of them to understand. Okay. Now, when it comes to the flip-flops, we can draw them. Okay, we can draw them. We can create them using both NAND and NO. Right? දෙකෙන්ම පුළුවන් ළමයි. හරි දෙකෙන්ම අපිට හදාගන්න පුළුවන් flip-flops. Now, those are called SR latch as well. So those flip-flops are called SR latch as well. Now, let me draw not draw, let me try to explain what is happening. Okay. Now, let's start with the no flip-flop because then it's easy for y'all to understand. The no part is easy for y'all to understand. Now, let me go to table here. And then Q and Q bar. Okay. Now, what is happening is now S is equal to set and R is equal to reset. Okay. Now what is happening here? I'll write it here because if I could draw the other gate in the other side, it's better. I don't know whether it could be possible, but it's better. So S is equal to set and R is equal to reset. Okay. So now imagine there is a light bulb, right? There is a light bulb. Let's say an LED bulb. Now, in order to control this bulb, imagine there are two switches, two separate switches called the set and the reset. Okay, this is very important. Now, there are two switches. Now, normally, of course, when we take a bulb, it has only one switch, right? In a practical scenario, most of the time it has one switch, right? On off, it's the same switch. But in this case, just imagine there are two switches to switch on the bulb, okay, to control the bulb, a set and a reset. Okay, now imagine I switch on the bulb. Now in here, set is 1, set in the no flip-flop, set is 1 and reset is 0. That is also important to remember because in the NAND flip-flop, it's kind of the opposite. So set is 1 and reset is 0. Now, at the first instance, what I'm going to do is I'm going to switch on the LED. So I'm going to switch it on. So then S would be 1 and reset would be 0, right? I'm just switching on the LED. Okay, I'm pressing the LED bulb. Okay, so I press the set button, and now the LED is on. So the LED is on. Okay, just don't worry about this part. I mean, may I worry about okay? Yeah, okay. I think the sound is better right now. Right, okay. So let's see now. If I set, okay, so this is one, don't worry about this one. Now, this is called a set instance. We are setting on the bulb. So this is called a set instance. Now in the next instance, what I'm going to do is I'm going to take my hand off this switch, right? I'm going to take my hand off this switch. So I pressed it. I pressed the set button. So I'm going to take my hand off it. But still, the light seems to be on. The LED seems to be on. Because now still we haven't reset the system, right? So still the circuit is looking at the memory. Still the circuit is looking at the previous output. So what is happening is still the light seems to be on. So that is called a hold instance, or we also call it as a latch instance as well. Now in the next instance, I'm going to reset it to the initial state, where the LED was off. So 1. Now what is happening is the LED is turning off. So this becomes 0. Now that is called a reset instance. Okay. And then what is happening next is, now I reset it. Okay. I'm going to keep it reset. So 0, 0, I'm going to take off my hand. But still, the light is off because still it is looking at the memory. Still it is a latch instance. Now, in this, just for fun, what I'm going to do is I'm going to press both of them together. Hari, dekama press karana. Dekama press karot. Now, that won't really do anything, right? You can him a ban switches we cannot press both of them together. No? Dekama press karanna bෑනේ. හරි. එහෙනම් මෙන්න මේ අවස්ථාව කියන්නේ මේ අවස්ථාවට අපි කියනවා not defined නැත්නම් invalid කියලා කියනවා. හරි. එතකොටත් මෙයා off-ම තමයි. Now that is called an invalid instance. හරි. invalid instance එකක් කියනවා. මොකද ඒ වගේ instance එකක් forbidden. ඒ කියන්නේ forbidden in the sense එහෙම කරන්න බෑ. ඉතින් Q එක මෙහෙම තියෙද්දි ඉතින් Q bar එක වෙන්නේ 0 0 1 1. මෙයා ළමයි පොඩක් වෙනස් වෙනවා. මෙයා 0 විදියටම ඉන්නවා. මොකද මේක අපි මේ instance එක වෙන්නේ නැහැ. මෙහෙම instance එකක් වෙන්නේ නැහැ. හරි. Okay, so that is how the no flip flop works. Now if you are drawing it, හරි මේක අඳිනවා නම් okay, හැබැයි yeah, NAND එක අඳින්න මෙතන නෑ. Come on, I'll erase it. Y'all can, go back and check, compare them. I just wanted y'all to compare them. But anyhow, it's fine. Okay. So this is how we draw it, right? Then we got another one from here. We got Q and Q bar. Now, in this case, in this particular case, the R should be on top and S should be on the bottom, right? Okay. There is when it comes to the NAND gate, it's the other way around. S is on top and R should be on the bottom. But now, normally it's better. Now, normally we start with the NAND gate, but this is a better explanation. Now, this particular example is a better explanation than starting with the NAND gates. That's why, I started with the new flip-flop. So anyhow, now let's check it, right? So 1 and 0. So this is 1 and this is 0. Now, when we all know that, so we are getting Q from here. So Q plus 1 bar. So we know that 1 bar is 0. So we get the answer as Q bar equals to 0. So we got the same answer. Then Q is of course equal to 1. All right, we can get the same answer as well. So we are getting this 0 to the top and bar. So 0 bar is 1. Okay. So likewise, y'all can check the other instances as well. Y'all will be getting the same similar answer, right? So this is how we draw the flip-flop. So no flip-flop. So the R should be on the top and it should be on the bottom. Okay. You should remember these instances. It's very important. Okay. Remember the story. Okay. Remember the story which I told you. Okay. The practical method, and then it's very easy to then answer it. And also, students, start with this instance 1 0. Okay. Now, in the paper, if they have given the instances and asking y'all to fill up these Q and Q bar, what y'all are supposed to do is, write this down in another paper and then fill it in a way. Now, normally they would start with 0 0 on the very top. Okay. So they start like that. No, they would start with 0 0 on the top. So, don't make any mistakes on that particular part. Okay, if you remember the story, then it's very easy. Okay, then let's move to the NAND flip flop. Now I'm gonna draw a similar type of Q and Q. All right, so in here, students, there is a bit of a difference. So, okay, so in here, the difference is now pressed. Let's consider it as 0. Not pressed, let's consider it as 1. Now, at the very first instance, I'm going to set it, right? So, this is pressed. No, I'm going to press this one. So, it's 0. It's the opposite, okay? Then this remains 1. So, the bulb is on. We call it a set instance. Now, I'm going to unpress it. So, what I'm going to do is I'm going to keep it on 1. So still the bulb will be on. So that is a latch instance or a hold instance. Now in the next instance, I'm going to switch off it. Okay. So I'm going to press the reset button. So the reset button is on. Okay. Then this becomes off. So this is the reset instance. So in the next instance, what I'm going to do is, now the reset is done. I'm going to the reset is on, and then what I'm going to do is keep it. So I'm going to not press it, but still the bulb will be off. So that is called the, once again it is called a latch or a hold instance. Now finally I'm going to press both of them together. So 0 0. Now this is called an invalid instance. Okay, so there is no it's like the same thing, right? It's the same thing which is done previously, but in here, students, for the example, consider 0 as pressed and 1 as not pressed. And in the previous example, we took it as the other way around. So මෙතන හිතාගන්න press කියන්නේ 0, not pressed equals to 1. So Q bar is again 0 0 1 1. Now, if you are drawing the flip-flop, the gate for this one, we are using NAND gates. then this is called SR. So S is on top and R is on the bottom, and this is Q and Q bar. In the previous one, we drew it in a way that uh, where R is on top, right? R was on top here. But in this case, of course, S is on top and R is on the bottom. So y'all can check an instance as well. Now let's say S is 0, this is 1. Now let's consider this one. So 0 dot, so we can say q bar is coming to this input. So 0 dot q bar, then 0 bar, then that's 1. So we got q as 1. Then once again here 1.1 bar. So 1.1 bar is 1 bar, that's 0. So q bar is 0. So we got this instance. So similarly, y'all can check the other instances as well. You'll be getting the same type of answer. Now remember these scenarios which I explained, and also if they ask you all to fill it in a way that you are starting from 0, 0, first write this down in a separate paper, okay, an extra paper, and then write in a way that we normally write the logic gates, right? We are starting from 0, 0, then 0, 1, 1, 0, then finally 1, 1, 1, 1, right? Okay, now all right, so that is the explanations for the flip-flop. Okay, now we have to cover, okay, in the next session, we'll be covering the full ladder with the half adders, right? There's a bit of a solving part as well in that case. So then that's it for this session. So let's meet in the next session.